Right, type 5 table problems continued. There's one free response and several multiple choice. This first one is 2016 AB number 1. We are allowed to use the calculator here. In part A, we are to estimate r prime of 2. Remember, r prime of 2 is the slope of the tangent line. We can estimate that by using the slope of the secant line, and we're going to pick two values close to 2. So I'm going to pick t as 3 and t is 1, and so I say change of r of t over change in time. We get negative 240 over 2, that's liters per hour over hour, or negative 120 liters per hour squared. In part B, we are to use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the first 8 hours. And then is this an over and under estimate, and give a reason for your answer. All right, so using integration, we can approximate using Riemann sum. We're using the left Riemann sum. So I'm going to just sketch the table here. So I'm going to start on the left at time t equals 0. And so our first height is 1340. Our second height at t is 1 is going to be 1190. Then at t is 3 we have 950. T is 6 we have 740. And those are going to be my 4 rectangles. You can use the calculator or just leave them in its unsimplified form, but that's 8,050 liters. Since r of t is decreasing, we know it's decreasing by the stem of the problem, then any left-hand Riemann sum is going to be an overestimate. So if we connect the dots here, we see that those rectangles are above the curve. In part C, we are to use our answer that we got in part B to estimate the total amount of water that's in the tank at the end of the 8 hours. And so we have our initial value, 50,000 liters that's in the tank at t is equal to 0, plus the amount of tank or the amount of water that's been pumped into the tank, and then we're going to subtract the amount of water that has been removed or left. And so using the calculator to integrate from 0 to 8 of this 2,000 e to the negative t squared over 20 dt, that gives us 7,836.195. Adding that to the 50,000, subtracting the 8,050 and to the nearest liter, that gives us 49,786 liters. All right, finally in part D, is there a time t when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed? So looking at each of these functions, w of 0 is 2,000, then we put w of 8, just substitute it into the given equation in the stem of the problem, we get 80.524. R of 0 from the table is 1340, R of 8 from the table is 700. Since we know both W and R are continuous, that's given in the problem that they're differentiable, therefore they're continuous, and we know R of 0 is less than W of 0, but R of 8 is greater than W of 8, then by the intermediate value theorem, there must be a time t in that interval from 0 to 8, such that R of t equals W of t, or the amount of water that has been pumped into the tank is the same as the amount of water, or the rate at which the water has been pumped into the tank is the same as the rate at which the water has been removed. All right, type 5 multiple choice. In number 8, we're also given a chart. We're given at t is equal to 0, at t is equal to 4, we have 50 liters of oil, and then in the chart we have a rate at which the oil is being pumped into the tank, and we're going to estimate the total amount that's oil been pumped from 4 to 15 by using a right Riemann sum. And so here are the calculations for the right Riemann sum. Here's a little picture for you to see. Adding those together with the original 50, we get that that's choice C. In multiple choice question 86, we're given that f prime of x is greater than 0, which means we have an always increasing function. And we're also given that the integration from 4 to 7 of f of t dt is equal to 0. That means the area underneath the curve is 0. So we have some sort of picture where the area underneath the x-axis plus the area above the x-axis, those are going to cancel each other out and get a total area of 0. Choice A is increasing, but all the values are below the x-axis, so we're not going to sum to 0. Actually, choice B is the correct answer. It's increasing and both has values above and below the x-axis. C is not always increasing. D is constant. E is increasing, but all the points are above the x-axis, so it's choice B. All right, the last multiple choice question for type 5. We're given some values for f prime in a table, and I've lightly just sketched them here. We know from the shape that f double prime, which are the slopes of f prime, are going to be equal to 0 at least twice. Okay, could be more, but at least twice. That also indicates that f prime changes sign twice. So if you look up here, we're decreasing in this interval, then we're increasing, and then we're decreasing again. Okay, so choice A says the graph is concave up. It is sometimes, but not always. Choice B, it says f has at least 2 points of inflection. That's our correct choice. That's where we know that f double prime is 0, but we also know that it's changing signs. So the slopes of f prime or f double prime are going from negative before 0, positive after 0 until about 5, and then negative again. So choice B is our answer. Let's keep going. Choice C says it's increasing. Well, not always. Choice D says has no critical points. Well, we really don't know that because the graph could drop underneath the x-axis, because to have a critical point, f prime has to be 0. And then f has at least 2 relative extrema. We don't know that because it has to cross the x-axis or equal 0. We don't know that.